Who jumps out of perfectly good airplanes in the name of science? Mr. C.
Well, 8th graders, happy Thursday to you. Yes, I can see the weekend from here, but I'm not going to do a little crazy, I can see the weekend from here thing. I'm not going to do that. So anyway, and it's a 3-day weekend. So anyway, you can look forward to that. So I have a jam-packed, chalky full of things that I've got to do today in 20 minutes. So I've got to hustle, my bustle. I got to really get rolling. So anyway, need your journals, because you might want to jot a thing or two down in your journals. Okay, good news, tomorrow, Friday, happy Aloha Friday, no quiz or test tomorrow. Okay, but I'm telling you this right now, I would make sure you kind of pay attention today to what I go over, because something could happen tomorrow that could earn you some extra points, let's say, and some of you could use some extra points. Some of you are fired up about getting extra points. You don't have to get them, but you're you're highly motivated that way to pick up every point that you can. Good on you for that. And that's kind of the attitude you really ought to have. Just, fighting for every point, wanting to do your very, very best. And that's why we're on the planet. So to please Jesus like that. Work hard in whatever you do, it says in Colossians. Work at it hard. Well, first, a few weather notes today. I was outside with the grandkids, and there were some gorgeous virga. Really pretty. So you never know when you're going to catch rain that falls out of the clouds and then evaporates. And you can tell what direction the high altitude winds are blowing at, because they'll blow the virga a certain direction. And you can go, oh, the wind must be blowing that way. So anyway, always be on the lookout for virga. It's always fun to see it. And then just a reminder that meteorology is an inexact science, and here's how. Local weather people here in Phoenix at the National Weather Service predicted that this week would be sunny, it would be clear every night. So I'm all pumped about telling you about Orion and its stars, and especially that the belt stars point down to Sirius, which is seriously bright. It's the brightest star that we can see from the planet. The sun accepted, of course, that doesn't count. The sun, our very own customized personal star, customized by Jesus just for us. So, and proof that he designed it. But anyway, so here we get clouds this week, so it's been tough. I haven't even bothered going out to look for Sirius, but I will go out tonight. It looks like it's cleared off. Now I'm taping this on Wednesday evening for Thursday. So anyway, maybe Thursday evening will be clear. So, and on Friday, in Friday's lesson, I don't have time today, I'm going to give you all the star data about the stars that make up the main stars that make up the constellation Orion. So I will tell you that, and I'm going to give you specific data about, and here I've got it all here. Look at all the data I've got about Orion and Sirius. For instance, I have on here how far away Sirius is. And one of the reasons it's the brightest star that we can see, it's relatively close. It's only like, let's see, I'm doing this in my head. So it's 53 trillion miles away, something like that. I'll tell you the number of light years tomorrow when I go over it, and some other really cool things about Orion. So that would be for tomorrow. Just a couple of other things really quick about the weather. On nights that were clear in the winter, especially in January and February, when we have clear nights, the heat that came in during the daytime can radiate into space more rapidly. If there's a cloud deck, it acts like a blanket and holds the heat in. So on cloudy nights, the temperature might only drop 15, 20 degrees Fahrenheit. But on clear nights are usually colder. So more heat that came into the Earth's surface can radiate into space, and the temperature drops about 30 degrees Fahrenheit. No charge for that. The clouds act like an insulating blanket. When there's no cloud layer, whoop, there goes the heat. It just whooshes into space, radiates into space. Now, so I've already told you about the stars. So coming up, I wanted to focus on the bat video that you saw. I'd like to focus on it, and I want to explain a few things about it. So easy peasy points if you did a good job on your bullet facts. So when you did it yesterday, which would have been your Wednesday. So anyway, what you saw about the bats, you saw some of the history of the scientists who studied bats. The first scientists who studied bats thought they were clumsy, thought they were simple animal life, and the Catholic Church even thought they were satanic, so which was silly, because when Jesus got through making all the animals, what did he say? They're good. They're good. So, but then Adam and Eve sinned, and it corrupted everything on the earth, including animal life. Originally, animals were designed not to eat each other, not to eat each other. They were herbivores. I've told you that before. It says that in Genesis chapter 1. But anyway, bats, not evil, awesome. They are awesome. Turns out, as scientists studied them closely, especially lately, you saw that senior citizen, I think when this video was made, he was 88, who was still studying bats, and it had kind of been a many-decade scientific obsession with him. It was sort of his specialty. Anyway, some of the amazing designs we've learned about bats, and then I want to tell you about the researcher who studied bats 200 years ago or more. And I want to explain why they portrayed him the way they did in this bat video. So anyway, we now know that bats have incredibly flexible wings. It's a thin kind of skin, and not only that, their bones are incredibly light. In fact, their bones are bendable. They'll bend because they're so light. Jesus made them that way. Try to bend your bones. Yeah, when your bones bend, what do? Break. Snap. That's not what we have in mind for our bones. They're not designed to bend very much. A little bit, but not much. Or they break, and then we get a cast, and they've got to heal up. So, by the way, just really quick, God designed them so even if there is a break, they automatically secrete kind of a glue that sticks them back together. Accident? Of course not. Of course not. So anyway, pretty cool. No charge. I'm not going to charge you for that. Back to the bats. One of the major researchers of bats 200 years ago plus, his name was Spallanzani. Was he Italian? Yes. Yeah. What gave you the first clue? Spallanzani. Anyway, he was a Catholic priest, a little bit like Gregor Mendel. So, and in fact, I know this to be true. The Catholic Church ponied up, as you say, a whole bunch of bucks. No, it wasn't him. It was a French scientist. But the Catholic Church, I'm sure, funded his research as a Catholic priest. But anyway, there was a problem, though, with his kind of letting everyone know that he loved studying bats, because the Catholic Church had declared bats evil, satanic. So if it became known that he was a bat researcher he could have gotten big trouble with the church. In fact, the reason they portrayed him as a little bit weird, I don't think personality-wise that's really the way he was. But anyway, he was fearful. He really was fearful of the Catholic Church getting wind of him studying bats, and then he might be defrocked or kicked out of the Catholic Church. So anyway, he kept it to himself. He would share with another researcher or two and ask them to verify his results. So did you notice that he used a scientific method? He tested all the different variables that could explain how a bat could see at night and still fly without running into things. He tested taste. He tested sight. Now, what he did to the bats back then, there weren't any rules in place for protecting animal rights like there are now. You can't do that in a scientific lab. The kinds of things he did, like poking the eyes out of the bats so they couldn't see. Be that as it may, he was a genuine scientist, really curious, and he tested variables, he controlled the variables, he formulated hypotheses. In the end, his major hypothesis about how bats could fly at night when it's dark without their eyes working. So what did he come up with? He thought that they produced sounds perhaps with their mouth, and then they could hear them and then avoid objects that they might run into. So like those strings that he suspended from the ceiling. In that test, the bats would do this. They would curve sideways like that and fly right between the suspended threads or string. Amazing. And he was just amazed at bat ability. And we are too, even more so, because we even know more about how amazing Jesus designed them, like he did all animals. But anyway, one of the scientists who studied them at Brown University, the one woman, doing great research, she's a great scientist, but she's an evolutionist. She has drunk the Kool-Aid that says everything gradually evolved. Now, she has to believe that. Does she really believe it down in her core? Maybe, maybe not. A lot of scientists are forced to say they believe the evolution idea, or they won't get funding. They'll lose their funding. They won't be able to publish their books. They won't be recognized. They'll lose their university positions, so they have to. If they really do believe God made things, most scientists kind of keep it under their hat. They keep it to themselves because they don't want to lose any of that stuff. A few scientists stand up, and they stand out in saying, look, the research that I've discovered, it could only prove there has to be a God. And there have been a number of them, especially in the last number of decades, that have lost their university positions and their publishing rights. It takes a lot of courage to say you believe in God and that God created the universe if you are a university professor. My major profs at ASU were evolutionists. And in fact, I've shared this with you before, I think. They told me that they had almost decided not to give me my master's degree at ASU for my scientific classes that I took because I was a fuzzy thinker, because I taught you there was a God who made everything. And that made them mad. Now, they still fairly and honestly had to give me my master's degree, but I almost had to be persecuted a little bit. Now, it was persecution enough to be in a meeting and have them call me a fuzzy thinker and think I was stupid because I believe in a God who made everything and that I teach my students that there's a God. But the evidence points to that. There's no other possibility. Anyway, so Spallanzani did all this research, controlled the variables, and came up with some great information. So, a good guy. Now, you've just started reading in your chemistry book. Your homework tonight is to do this. Your homework tonight, if you'll take out your periodic table of the elements. Camera's not focusing so well. Sometimes it does. So if you'll take it out and look at it, and I'm going to tell you just a few of the elements that you've got to know if I haven't done this already. So you'll want to highlight them and maybe even make a little note or two. So by the time we get through, you're going to have to know about 20 to 25 of these symbols. You guys are so smart, you could memorize them in one, probably hour or less, and get a perfect. Because you have young brains and young memories, and they work really good, especially when you triple R. They work really good. You can learn and memorize very quickly. So some of you know that already because you cram for my test last minute and still do well. So I'd rather have you triple R because I want you to remember a lot of this for a long time and not just for a test, for 1 hour for a test. So anyway, first you have the bookend elements. What do you call the basic kinds of atoms? They're called elements. So the next test, of course, I'll ask you that. And this is the periodic table of the elements. It's just a chart that has periods. I've already told you that. The elements are organized into groups called periods based on like properties or characteristics. So you've got the bookends, H on the upper left, H for hydrogen gas, it's a gas. And then you have helium gas on the right side, upper right. Both gases are found on the sun. About 73% of the sun is hydrogen. And you already know what happens with hydrogen. You might want to write it in the box. Hydrogen atoms, because they're heated up so fast, slam into each other. It's called fusion. They fuse together and produce helium, the other gas on the sun, and heat and light. Jesus designed the fusion process to make heat and light for us on the earth. Not an accident. Just everything fits. Everything just has a reason, a purpose in God's creation. And so do hydrogen and helium. So hydrogen to cause fusion on the sun and make heat and light, and to make helium also. Helium, of course, a lighter than air gas. You put it inside of an envelope, a balloon, and because the gas and the envelope are lighter than the air around it, they rise. So helium gas. So hydrogen is explosive. If you heat up hydrogen, it'll blow up. You heat it up, boom, it blows up. So we figured out that early when we used to make, 100 years ago, dirigibles or massive blimps with hydrogen in them. It was lighter than air, and they'd come across from Germany to the U.S. They were quite slow, so it took several days to come across the Atlantic. I don't know how fast they went. I don't know, 20, 30 miles an hour. But anyway, one of those dirigibles, when it was docking, there was a spark and it blew up. Some of you have heard of it before. I might show you the explosion of the von Hindenburg, the name of that blimp. So, excuse me, I'll try to remember. So anyway, these are elements. There you've got two already. Hydrogen, it's explosive, lighter than air. Helium, lighter than air, not explosive. Both gases found on the sun. Hydrogen causes fusion. Hydrogen fusion, and then helium is produced, heat's produced, and light is produced. Next test, of course, I'll ask you on that. There are elements on this chart that are solids. There's one that's a liquid, some are man-made. Anyway, a whole bunch of different properties. So, more on all of that later. My time is almost up. I wanted to show you this. Hope I have this here. Let's see if I do. Yep, there it is. I want to just revisit really quick your superpower. Your superpower is everything about you. Oops. It's your Go Tappy package. See that? Go Tappy package. It's everything about you. G for gifts, opportunities, talents, abilities, 3 Ps, personality, physical appearance. Your DNA gave you that God gave you. And then your purpose. God has designed you for a purpose in His kingdom. If you'll go with it, if you agree to let Him use you, He will. It's awesome. And then, so it's Go Tappy, G-O-T-A-P-P-I. The I is made in God's image. You see that? And then all of this, when you're a believer, is controlled by the Holy Spirit. You can see I've got Holy Spirit under there. So how cool is that? Now, I am going to turn over the class for just 8 to 10 minutes to my daughter Laura, and listen carefully. You'll want to stick this in your journal. I want you to come up with 2 to 3 things that she says about what you can do. She's going to really drill down into how you can develop some aspect of your superpower. She's going to tell you how to develop it. And there's scientific research behind what she shares. So you'll want to really pay attention. And I know you're going to find it interesting. So 2 or 3 things written in your journal, and take it away, Laura.
Hi, this is Your Magnificent Brain, Learning with Laura. And I wanted to do kind of a part 3 of your superpower. I know last time we talked about some of the things that we can do to improve and invest our time to kind of invest and develop and improve in the different areas that we're interested in. But I wanted to go back in and really talk about why we use that term leveling up. And this was very purposeful. My dad and I had a conversation about how to really show and really discuss even the process of increasing your understanding, increasing your levels of ability. And the reason why we chose leveling up, and it's very much a video game metaphor of allowing your experience, the time you put into something, to really help you reach the next level of understanding, the next level of skill, the next level of improvement. So it's really purposeful. As we talked about last week as well, or the last time I spoke with you, I think it's 2 weeks ago now, we talked about you are constantly in a state of transformation. You're constantly changing. And that's great, because it means that what level you were at yesterday, if you work at it today, if you work at it tomorrow, you'll improve over time in whatever area it is. Whether you have natural ability, whether you have to work extra hard at it, whether you have to kind of cultivate and really figure out how you even learn best in something, you will improve. I've heard a lot of things recently about people talking about how to gain a level of expertise in something, and you'll hear numbers of hours. You'll hear, it takes 10,000 hours to become an expert at something, or it takes 6 years of dedicated time and effort to become an expert. And what I'd say is all those numbers are kind of arbitrary. Really, it takes the amount of time that it takes for you to get really good at something. And even better, in terms of a way of looking at it, is if you work at it today, you will improve. if you work at it over time, if you work at it consistently, you will continue to improve each and every time you work at it. And I think there's something really comforting about knowing that each time you work on something, you're taking steps forward. It really doesn't matter. The ultimate goal isn't necessarily getting those 10,000 hours or those 6 years, whatever it takes to become really good at something. All of that almost is besides the point. If you want to work at something, just work at it. Invest in it. Take the time, effort, energy to continue to get better, to continue to invest your time in it, and that leveling up will happen. So I also wanted to talk about the subject of grit, the idea of grit. There's a lot of research studies out there right now that look into performance, basically how individuals perform in any type of performance situation. They found that people do better in those situations, regardless of their actual talent, ability in a given area. They do better when they have high levels of passion for what it is that they're doing, so investment from an emotional standpoint, and also high level of perseverance or stick-to-itiveness. So basically, what this research is showing that how we perform, how we actually do in different situations, some of that we own by our level of perseverance, our level of interest in what it is we're doing, and by actually digging in and finding grit, we can improve our performance. And for me, that was very encouraging because it meant that natural talent, natural ability can only take you so far. And by choosing where you invest your time, by choosing the things that you want to have grit with, that you want to be invested in, that you want to actually persevere in, by choosing and actively doing it, you will get better. You will be able to basically perform at a level similar or even potentially better than the people that it comes naturally to. We talked 2 weeks ago about several things you can do. Basically, I gave you 5 different things that you can do to work on getting better at something. And what I wanted to revisit with them is giving additional ideas of what you can do to basically just continue to improve, use that grit to improve your performance over time, to level up. And the first one we had talked about was finding motivation. And we had talked about finding your why and reminding yourself of your why. And as I was thinking about it over the last 2 weeks, I was considering in what ways I remind myself of why I'm doing what it is I'm doing. And what I found is having like a note board somewhere where you put a little sticky note that reminds yourself, work on this, work on your writing, or work on your, if you want to play basketball, work on shooting hoops, work on fundamentals. If you want to work on learning a given skill, a language, putting something up there that reminds you to do your vocabulary. Things that will remind you and help motivate you. That every time you see it, you're reminded of why it is you're doing something. And words, especially your own words being reflected back to you, they have a lot of power. Measuring or tracking your progress. And what I found with measuring and tracking my progress, one, making actual goals that can be met, making sure that they're realistic. So if you're wanting to go from not running at all to running a marathon, making sure that you're looking at it, okay, I'm going to go running for a mile 2 times a week, and then slowly upping that over time. But in addition to setting those goals, like I talked about 2 weeks ago, track in a way that you can actually go in and check mark things off, because that feels really satisfying when you see all the number of times that you met your goal. So on a calendar that you look at, or a planner, or even just keeping a little tally of how many times you did this thing. You went for a run even when you were tired. You went out and shot hoops. Any of those things where you can have that tally marker, that check mark that shows that you did a thing, and you can celebrate that you've accomplished that. I talked about learning from experts, and I wanted to revisit that because I know I mentioned, YouTube videos, but what I would say is, if you know anyone who has expertise in a given area that you're seeking to aspire to or move into, it doesn't matter how old they are. They could be in the next grade, they could be a friend of yours, they could be someone who's a lot older. Anyone who has more experience than you, listen, mark what it is that they're saying, pay attention to what it is that they're saying, and even potentially write notes, or after the fact, if you don't take notes as you're talking with them, write down what you remember from those interactions. Make sure that you capture those things so that then you can apply them at a later point. And then we talked about practice, practice, practice. Don't just learn about a thing, but take the time to actually take what you've learned and apply it. Again, if you're looking at a sport and you've heard someone talking about that sport, go out and try that thing, whatever it is. If it's a certain way of shooting the basketball, if you're interested in writing and there's a specific way of writing that you've found that you find intriguing, do it. Just try it out. Don't judge yourself for the performance. Just do it, try it, see what happens. And then I talked about taking on challenges and being willing to risk something, being willing to push yourself, even if it's something that's a little bit out of your comfort zone. If it's you're learning how to play the guitar and all of a sudden you have the opportunity to play in front of people, take those opportunities. Try. See what happens. Usually we're nervous and afraid of doing something, and then once we do it, we gain that confidence to keep doing it over time. And I would highly recommend that those opportunities where you can try, where you can do something that's a little outside of your comfort zone, but that's still within your capabilities, take those opportunities, because then you'll have that win underneath your belt. They'll have that situation in which you've tried something, you've seen that you can do something, even if it wasn't perfect. So I hope this is helpful, going this next layer in really working and investing in the things that spark your interest and curiosity, continuing to really emphasize that you listening to yourself, what engages and interests you, and then taking the time that you have to really invest in you and your interests is important, and really over time can be life transforming. I hope you have a great rest of your day, and I will talk to you in another couple weeks.